Welcome to part 2 of how an accumulator works. In this video, we will see how a finite product of a sequence is calculated using programming languages. Consider the finite product k from 1 to 5, which corresponds to factorial 5. The pseudocode segment for this product is given as follows. Here, the variables are s and k, and their memory locations are represented with boxes. Some programming languages initialize variables to default values, 0 or none. If a variable is explicitly set to 0, then the memory value at that location will be 0. So we assume the memory values of s and k before the code segment are 0. The first executable statement of the code assigns 1 to accumulator variable s. Note that the memory location of s is updated to 1. In recursive multiplication, the accumulator variable is always initialized to 1. The for loop iterator starts with 1, which initializes k to 1. Also notice that the memory location of k is updated to 1. The value of k is less than 5. So the loop will go on to execute the statement block. The right-hand side of the executable statement is evaluated first, which yields 1. The result is overwritten on s. That is, its value is moved to the memory location of s. The loop, after executing the statement, returns to the top, where the loop iterator takes the value of 2. Note that the memory value of k has been immediately updated to 2. Since the iterator, k, is 2, which less than 5, the next statement will be executed. When the right-hand side of the executable statement is evaluated, the product is found to yield 2. This result is overwritten on s, and the product value is placed to its memory location. The loop returns to the top again, where the iterator takes the value of 3. Because the iterator k is less than 5, the next statement is going to be executed. The right-hand side of the statement is evaluated using the memory values of the variables 2 and 3. Their product results in 6. The product, 6, is placed into the memory location of s. The loop returns to the top, and the iterator takes the next value, 4. The memory value of k is also updated to 4. Since the iterator k is less than 5, the next statement is evaluated. The right-hand side of the executable statement is calculated using the memory values of the variables s equals 6 and k equals 4. The result of the right-hand side, 24, is moved to the left-hand side, that is, to the memory location of s. The iterator takes the value of 5 when the loop returns to the top. The iterator k is equal to 5 the last value of the for loop. The executable loop statements will be executed. The right-hand side of the statement is evaluated using the memory values of the variables 24 and 5. The product on the right-hand side, 120, is overwritten on S on the left-hand side. That is, the memory location of S is updated to 120. As the iterator goes to the top, it is incremented by 1, yielding the value of 6. Since the iterator value becomes greater than 5, the loop is terminated, which is 5 factorial. See you next time. Bye.